Thank you very much for the opportunity to present here at the Korea Supercomputing Conference this year. It's my honor to be here and share a little bit more about my story from how I got into supercomputing. And I'd like to share some of the trends we're seeing for computing across the enterprise. So to get started, I'd like to share my personal story. So I was an engineer more than 20 years ago at Boeing, designing the 787 Dreamliner wing design. And of course, as you know, to design the aerodynamics and the structures, this is a very difficult technical challenge. So we used many different on-premise HPC systems and supercomputing centers to try to solve this problem. However, we were trying to apply machine learning to optimize the wing. In this case, it's a composite wing design. So very challenging design with carbon fiber, many different layers, and more than 20 million variables, all changing at the same time. And at the same time, we're computing the aerodynamics, the structural design, the manufacturing constraints. And to solve this problem, we had to use many of the different HPC centers that Boeing had at that time. So we used over 80% of Boeing's compute power. And it took us many years of writing software to be able to leverage this big compute capability. But once we solved this problem, we had some incredible results. So at Boeing, we were able to, on the 787 Dreamliner wing, improve the design by over 150 pounds, which saved over $100 million for Boeing in their final design delivered to the different airlines. So this was an incredible engineering improvement in reducing weight. And this is about 15 years ago when we delivered this. The other more important element was we were able to accelerate the product development time from 3 months down to 24 hours. In fact, the reason it was 24 hours is we were only able to get the compute capability in Boeing over the weekend, because that was the only time when the other teams not using the HPC system. So after writing this software, we had these incredible results. And based on this experience, we decided, instead of having to write the software, it's very important to have a compute platform to be able to allow the end user, using the use case on top of the HPC or supercomputing system, to be able to get access to all the compute power that they might need to solve the most difficult technical challenges. So for this reason, we decided to start the company Rescale. And we founded this company now almost 8 years ago. And we decided to build a software platform to help end users solve those most innovative challenges in all the different disciplines, from automotive to manufacturing to aerospace to life sciences, financial services, and many other applications. And this platform, when we first started, it was very challenging from an engineering standpoint. Because at this time, you have public cloud with virtualized infrastructure, you have supercomputing centers, you have bare metal data centers, and customers' own HPC center. So Rescale built the big compute platform to be able to help access any of the hardware across any of these. And when we start this company, we also were lucky to be able to be funded by people like Jeff Bezos invested in our company, Microsoft, Richard Branson, Peter Thiel, and many other people. So at this time, now, many years later, we've raised over $50 million to be able to build the best possible platform for you to be able to help accelerate innovation. So I'd like to share a quick video on our experience with Rescale. I think the audio needs to get turned on. switch the audio. Okay, maybe we don't do the video. So I'd like to share some of the trends that we're seeing with many of the customers that we have on Rescale today. So the first trend is on Moore's Law and processor specialization. So as you know, Moore's Law has delivered incredible improvements over the years in computing. And Moore's Law is continuing to go forward, but it's decelerating. And it's increasingly challenging because chips can only be made so much smaller. So there's some ceiling and limitations that you can see in the single-threaded performance, which is why you see many processors with many cores to be able to scale up the compute capability. So this is a key challenge in HPC, is how can you get the increases that Moore's Law has delivered over many years, but still be able to maintain software that can run on chip architectures that are more standardized. The second challenge is further specialization in processors. So in order to get the gains that most companies and software expect on the hardware level, we see many companies developing their own chips. So the largest companies in the world, for example, Apple, has developed their own chip because the off-the-shelf chip cannot deliver the software performance that they're looking for. So here you can see this is the Apple A12 Bionic chip. This is very recently released for the iPhone SX or XS. And this is a system on a chip with 3 different types of processors all in a single chip. So first of all, the 6-core CPU is a 7-nanometer chip. So actually, this is quite impressive because the 7-nanometer chip is not available for most people. So you can see that actually enterprise companies are starting to develop their own chips faster than a typical chip maker. So this is a quite interesting development. On top of that, for an iPhone, you also have graphics and machine learning type capabilities. And so they also have a GPU chip and a TPU chip, or essentially, it's not exactly like a TPU, but similar to a TPU of a custom chip for machine learning built into a single system on a chip. So this trend actually creates, I think, a very interesting dynamic in the industry, because now it's not that the hardware is built like a supercomputing center and you put all the software on top. It's actually you're designing the hardware for the software. So this is changing the dynamic of how people are looking and investing in this industry. So the second level above that we see is on the server side. So you see the fragmentation on the chips and Moore's Law slowing down. So in order to get those speed ups, you see also fragmentation on the server side. And this is just a generic view of all the different spectrum of different capabilities that are available at the processor and interconnect level. But this is increasingly fragmented. So there's many more releases of custom chips, FPGAs, GPUs, and different CPUs, and these are all being released at an increasing rate. So for an HPC and supercomputing director, this is a big challenge because these new releases are coming all the time. How can you make the right investment at the right time for the right requirements? On top of this, the overall data center approach of building a large data center and keeping this for 4 to 5 years is a quite challenging way to serve this environment. Because if in 6 months your hardware is already old, it's very hard to stay up with that capability. So this shows that maybe it could be interesting to have a platform that lets you access many different hardware capabilities and share those resources for when you need them. And the third big trend we see on computing is a move towards hybrid. So as far as hybrid goes, we see most enterprises, and now I think Gartner has said it's over 73%, are deploying their on-prem system extended to the cloud environment. So this capability shows, and this development shows, that it's not just good enough to have the on-premise environment, you have to have the extension to cloud to be able to bring the latest capability to the end user. And so, according to Gartner, this environment and the software to support the hybrid cloud is over $317 billion industry. So, of course, that's why you hear many of the major vendors talking about hybrid solutions. But the key thing about hybrid is really a mentality. You have to extend beyond your own data center, and you have to extend that capability from a security, from a networking perspective, and also from a performance and data gravity perspective. So solving the data gravity challenge is a key challenge when you move towards hybrid. If you don't know what's data gravity, it is essentially that the data, where the data is where you want to do the compute. And so HPC traditionally is built with the small input files, lots of computing, and lots of output. And so this process is very well suited towards a hybrid environment. Move small amount of data, do lots of processing, and then have the output data there. But you also have things like machine learning, where you have a lot of input data. And so when you have a lot of input data, you have a big data gravity challenge, which is wherever the data is, you want to bring the compute to the data. So this is why you see this trend also of edge computing, is because you have the data already in one location, you actually want to bring the compute to the data set. And we see many companies starting to do this. But most importantly, you need to think, no matter what you do, of a hybrid architecture. Because data is coming from many different places. And you want to do compute across many different architectures. So at a platform level, you need to think about how can you solve this problem in order to run the best possible and most performant software. And then the fourth trend that we see is multi-cloud. So across many of our customers and many of the industry leaders, we see not only a commitment to a single cloud, and maybe you have one big strategic cloud partner, but you actually have a multi-cloud strategy. And the reason people have multi-cloud strategy is there's great cloud vendors that are out there, but the investment in the hardware is happening at a very fast rate. So it's critical that you leave yourself not locked into a single vendor to be able to rely on their refresh rate. With a multi-cloud capability and along with hybrid, you have the opportunity to get the best hardware from any vendor at any point in time and get the best price and the best performance. And so we see at a critical kind of time, most of the enterprises are moving to this kind of multi-cloud capability. And a platform strategy allows you to be able to do this. So we believe that a platform environment allows you to plug in the right hardware at the right time when you need it for the right price and the right performance. And this is the Gartner quadrant. So you see, of course, Amazon and Microsoft as leaders. And the cloud platform strategy allows you to, as other players build new capabilities, and also as you might want to partner with local players in Korea as well, this kind of platform strategy can be extremely effective. And together, the platform approach requires a new thinking of how to think about computing. So we believe at Rescale, this is software-defined computing. And you might think, infrastructure as a service is already something like software-defined computing. But actually, software-defined computing is really a change in mentality in how you think about compute capability. So computing is not only about the hardware and then throw the use cases and the workloads on the hardware. It is critical that we believe, and what we see is critical that enterprises start thinking about workload-centric. So start with the workload and build the infrastructure that you need on demand, on the fly, for the workload that you have. And this type of thinking is the most effective approach to be able to the most cost-effectively and the most performant environment for the computing capabilities. And so software-defined computing, it's similar to like software-defined networking, which you probably already heard about. And it is to move away from the hardware layer and move into the software layer to solve your problems. So you can actually use an API and use the software development cycle in your company to help integrate the best possible compute capability. And you don't need to think about what specific chip architecture, what servers, what vendors, which clouds. You have a software layer which automatically select the best possible hardware for your use case. And this approach is the future that we see of how the best companies in the world are using computing capability. And in a software-defined computing world, everyone still has a critical role. So the HPC experts are building the infrastructure supporting this. The on-prem and cloud hybrid environment is also supporting this type of capability. And they're the fuel to be able to run the software-defined computing, software connected to this infrastructure. So this is a centralized layer to be able to intelligently allocate the computing capability into the enterprise environment. And so this strategy is where we see the future of computing going. And there's kind of two components that we are seeing at the enterprise level. So one side, especially here at supercomputing, is critical, is the technology. And this is probably the most important capability. How do you get the most performant stack all the way from the workload and the use case down to the infrastructure and chip level? So on the left side here, you can see the technology intelligence. And so the HPC platform approach is to think about, you have many different use cases in your company or in your university. How do you serve all these use cases? For every use case, you have different software applications, and you have different other components in the stack, from the compilers, the operating system, all the way down to the networking and the server architecture. But there's many, many different choices here. So this is a key challenge, is how do you pick the right environment and the right stack to be able to run those use cases? And an HPC platform with a software-defined computing approach helps solve this problem for you. So this is why we think that the platform capability is really a critical engine to be able to take advantage of the best possible compute that exists. The other side of the platform is the economic intelligence. So this is like the business layer. So as you might have seen, is different cloud players have many different server SKUs and many different pricing models. And on top of that, you have different vendors and on-premise at different prices at different times. So this is a very dynamic environment. And so the business case, if you're sitting in an enterprise company, it's critical that you can, on demand, decide what is the cost going to be able to run this compute capability, and how can you get it done in the most efficient way possible, and connect that the actual business case is connected to the computing and the IT capability. In most companies, you have a CIO and an IT environment running the supercomputer and the HPC system. And on a different side of the organization, you have the end user and the business unit and the rest of the organization. And they use the compute service. But the HPC platform, especially if it's a cloud platform, it allows you to start connecting the business choices in the business side, connected to the IT choices on the IT side, and together solve these problems much more efficiently and much more effectively. Of course, this is together with an on-demand infrastructure like a cloud environment where you can make the investments very quickly and effectively and only pay for the capability that you're actually using. So we believe that this computing platform, and this is an example like Rescale, and there's many other players that also are building different capabilities for this environment, like the infrastructure. Of course, you have Amazon, Microsoft, Google, IBM, Dell, HP, and other on-prem providers. But all of these different hardware vendors can together provide you the best possible infrastructure capabilities for your workloads. And then on the top, you have the application providers. And the software vendors, they're also trying to figure out how can they cloud enable their software, and how can they make it available with things like pay-per-use licensing and different business models in order to support the on-demand environment that the end user is looking for. And the key technology that Rescale is investing in and developing is this software-defined computing between the application layer and the infrastructure. And we believe that if you can fully integrate this stack of tools and deliver that in an on-demand environment, this provides the best possible environment for computing for the end user. So we've developed this, and this helps support this software-defined computing environment. And there's 3 other major trends that we see in these big enterprises. And you've probably heard of them. One of them, at least, is big data. Then we also see a shift towards big compute, which helps support the analysis of the big data. And then the last big trend is the digital transformation. What are you actually doing with computing capability that's driving a change in your organization and driving the change in the innovative capabilities that a company and a university has? So as far as big data goes, it is important to take a minute to think about how much data is really being generated. It's an incredible amount of data. So in the last 2 years, 90% of all data that exists in the world has been generated. So this is growing at an exponential curve. And also the storage capabilities of many companies and enterprises are growing at an exponential rate as well. So the amount of data that is being collected by everybody is massive. But what are you going to do with all this data? How can you process the data and get the insights? Because without the insights, the data is just data. So we believe that most people need to build big compute capability. And what is big compute? It is just like HPC, but it is thinking about it at the workload level. How can you use computing to solve some of these big data challenges and use it to drive the insights into the enterprise environment? And finally, this leads to the digital transformation, which is the end user and what the company and the innovations that the company can deliver with this type of environment. And so the digital transformation is kind of the key word that you maybe have heard in many different industries. And this is talking about manufacturing company becoming much more like a software company. That the intelligence and the expertise that's being done in the manufacturing process, for example, like developing a car, is actually being digitized, captured in the software, and captured in the algorithms in order to deliver the final insights. And allowing this allows you, providing this kind of environment allows you to scale the digital transformation and digital capabilities of enterprise companies. So to talk a little bit more about what this really means, I wanted to share some of the stories of our customers at Rescale and what they're doing with the future of computing capabilities. So this is near and dear to my heart. One of our customers is Boom Supersonic. So of course I came from a big company like Boeing with hundreds of thousands of people and doing this development on 787 Dreamliner. But now we are providing compute capability to the next generation aerospace companies, the next Boeing, the next SpaceX. So Boom is developing the next supersonic jet. And this jet is going to be delivered, or the first time it's going to be flown is next year. So this is a very exciting time. And this entire jet is 100% built in a cloud platform. All the aerodynamics, all the structural design, the entire end-to-end product development system is built in the cloud platform. So this shows the incredible capabilities that the latest companies can use. It's not only, though, in the enterprise, it's also in academia. So this is a university, this one is in Japan, and they bought one of the largest supercomputers last year. And they deployed Rescale as part of that supercomputer as a platform to be able to extend to the public cloud and extend to other supercomputing centers around the world. So this is a very key, interesting use case. If you think about software-defined computing and think about a platform, it's not only about the cloud. It's actually about using the cloud as a distributed platform to leverage the investment that's happening on the hardware in the data center as well. And this resource is shared across many different end users and different use cases because now it's delivered through a cloud platform. Another interesting company that we've worked with is one of the largest automotive companies in the world. And they are using this kind of cloud platform capability to massively scale up their ability to do the simulation. And even as a very large company, their crash simulation need is going up and down all the time. So they're able to get a turnaround time speed up of over 300%, so 3 times faster in order to do the crash simulation for developing the vehicle. And there's many other use cases and applications in the automotive space as well. Another key use case, in this case for computing, is around AGC, which is one of the largest, I think the largest glass manufacturer in the world. So they're developing material science capabilities for different glass and material innovations. And they were able to use this software-defined computing approach and this platform, so from 40 hours on a workstation into a distributed computing capability of just 10 minutes. So this is not only accelerating your ability to do the same thing, this allows you net new capabilities and solve problems that were never possible before. This is very impressive how quickly also they delivered this capability to the end user, because they were able to deploy this, a very large enterprise company, and deploy that very quickly to the end user. Another example is in a very different world of EDA and electronics design. And this customer, P-Semi, they're able to accelerate their EDA process. So this is electronic design automation, using on-demand computing capability and accelerate by 10 times with a 40% efficiency speed up for electromagnetic simulation. So again, this is a quite incredible use of computing and use of simulation that wasn't possible before without this kind of platform approach. Another example in a very different field of life sciences. So this company is Metabiota, and they are essentially developing the algorithms to help evaluate when a disease spread throughout the world, both the science behind how the disease spread and the transportation patterns. So when you have an outbreak of Ebola in Africa, for example, they can measure how the disease will spread and how should the government respond to an outbreak of a disease like Ebola, like SARS, any of these. And so this kind of simulation capability with the software-defined computing on demand allows you to get a better response faster and save lives of different people. So this really touches, the entire spectrum of everything you experience every day in life, how computing contributes to advancing our society forward. Another area in life sciences is bioinformatics. You're probably very aware of this big trend of lots of sequencing. So accelerating the sequencing capabilities is something that is really critical to help advance drug discovery and help do diagnostics and detect drugs, or detect the diagnostic diseases more quickly and develop drugs more efficiently. And so this company, they were able to improve their sequencing, especially the cost. So another reason that a platform at the computing level is very critical is you're not only able to get the best possible performance at any time, but you're also able to get the most efficient cost. And this allows you to unlock new capability, because when you can reduce the cost of computing for the end use case, they're able to deliver more sequencing to the patients that this device helps serve. And this is a very cool project by Airbus. So this is a vertical takeoff and landing vehicle. So it's actually like an air taxi. So they built this and already tested it. And this aerodynamics for this vehicle were done very quickly. In just less than a year, they developed this design. So this is a very innovative project, and they were only able to do this kind of very quick product development with its platform capability for the computing. And this, again, shows that all the next generation innovations are being developed on these very dynamic platforms. And computing is critical. Without computing, you cannot do this type of quick development. Another impressive use case here, this is automotive company developing components. They were able to experience on fluid dynamics over 500 to 600% speed up by using a platform to get to the fastest compute capabilities. So they were working on this for many years already, and by using this platform, they were able to get 6 times faster. So incredible speed up. This is a Formula One company, or Formula One racing team, that leverage this kind of platform capability in a very interesting way. So they actually instrument the Formula One car with sensors on the car. As it's racing around the track, all the data is streaming into the cloud. And then you can do the computing real-time, processing of HPC system, and the feedback back to the driver and back to the pit crew. So this is a very interesting use case, is leveraging both the IoT use case of on-the-car data collection, and then doing the software-defined computing up in the cloud to get a real-time feedback. And this car is racing all around the world. So they're able to do this in any location because they have different data centers close to the track in these locations. And finally, one of our first customers where we started the company was with space companies. So this is a rocket development company you might know, but it's based in North America. And they were able to experience over 24 times speed up of developing the propulsion system, running more than 10,000 different CPUs at the same time and lots of simulations. And that allows them to develop a rocket many times faster. And this company actually developed a rocket 3 times faster than the Boeing and ULA Joint Alliance, a typical rocket development company. So it's incredible speed up. So these type of companies, without the computing capability, would not even exist. So as the HPC community, we are critical to help enable this next generation of innovations. And the more efficiently we can provide this capability, the faster as a society we can move forward. And finally, the last case study I'd like to talk about is LSIS. So this is not very far away from here. So LS Group and different divisions, but they built the first engineering cloud in Korea for HPC and CAE capability. And by doing this, they were able to go from 300 hours to just 10 hours. And this is really a first in Korea. So this week, LSIS actually won the IDC Digital Transformation Award for the best digital transformation capability here in Korea. So this is really impressive accomplishment by a Korean company to be really one of the leaders in the world in deploying this kind of digital transformation capability. So I'd like to leave you with just thinking about these major trends is very critical about how the server and chip manufacturing environment is really changing how you should think about deploying your computing capability. And most importantly, is to think about it not only from a hardware perspective, but think about it from what is the use case and the end user that is leveraging your supercomputing center and your HPC capability, and how can you use a platform and a software-defined approach to get the best possible hardware and the best possible capability for those use cases. Because those are the reasons that we have the HPC community. Those are the reasons we have the Supercomputing conference, is to try to bring the best possible computing to the end user. And we can only do this for our environment if we build a platform that connects all the compute capability together to deliver those best use cases to enable companies to do this kind of digital transformation and push the innovation forward. So I think this is very critical, and I hope that many of you will join us in helping push the industry forward and able to bring this kind of capability. So lastly, I'll try to show the video one more time. Hopefully the audio will work. No? maybe they will help. Let's see. No. It's okay. Yeah, no problem. So I think you can go watch the video yourself on your phone. Okay, that's it. Thank you very much.
오케이, 땡큐. 강연해 주신